If you had to describe math, how would you do it? Other types of science are easier, right? Biology is the study of living things. Chemistry is the study of elements and their properties and what happens when you mix them together. Computer science is the study of computers. But what is math? What is math the study of? Well, one way to think about it is that it's the study of numbers. We all know what numbers are. 1, 2, 3, 4, those are numbers. 1,475,367, that's a number. Even things like -4, -400, 3.14159265535, that's a special number called pi, right? But that seems like a kind of funny thing to study, right? What is there really to study about numbers? Well, people have actually been interested in the properties of numbers for over 2,000 years. Mathematicians in ancient societies like in Greece and Egypt were fascinated by numbers. Now, what do I mean by properties of numbers? Well, we can classify numbers in different ways, right? Some are positive, some are negative, some are even, some are odd, some are whole numbers, and some are decimals. And the specific property of numbers I want to talk about today is called prime. So what is a prime number? Well, if you were to look it up, the definition is a number that is only divisible by itself and 1. First, we need to talk about divisible. Divisible means that when you divide a number by another number, it gives a whole number as an answer. So for example, 6 is divisible by 1, 2, 3, and 6. Is 6 divisible by 4? Well, 6 divided by 4 is 3 over 2, or 1.5, which is not a whole number, so no. Is 6 divisible by 5? 6 over 5 is also not a whole number, so no. So how did I know to stop trying to find divisible numbers at 6? Why didn't I test 7 or 8 or bigger numbers like 100? Well, if you try to divide a number by something bigger than itself, for example, if I tried to divide 6 by 7, that number will always be less than 1. So we know that dividing a number by a number bigger than itself will never give a whole number, so we don't need to test if any of those numbers are divisible. Returning to our definition, we can ask now, is 6 a prime number? Well, we showed it was divisible by 1, and it's divisible by itself, but it's also divisible by 2 and 3. So it's not a prime number, because a prime number is only divisible by itself and 1. Some examples of numbers that are prime are numbers like 2, 3, 5, 7, 11, 13, 17, and so on. I encourage you to test these, make sure these are actually prime. And can you tell me if 27 is a prime number? Why or why not? Okay, so I have a list of prime numbers going, but now you might want to ask, how many are there? And we would not be the first person to ask this question. In fact, around 300 BC, over 2,000 years ago, a philosopher and mathematician named Euclid asked the same question and wrote down a proof that there are infinitely many prime numbers. This means that prime numbers go on forever. We will never be able to find all of the prime numbers because there are infinitely many. They go on forever. This seems really difficult to prove, and in fact it is difficult to prove that there are infinitely many prime numbers. Euclid used a special technique called proof by contradiction. Sometimes in math, if what you're trying to prove is really hard, it's easier to assume the opposite and prove that that's not true. In our example, to assume the opposite, we would say, okay, so there are finitely many prime numbers, which means we can write them all in a list, and they don't go on forever. The next step is to show that that is actually impossible. Then you found a contradiction. So if there are not finitely prime numbers, if we show that that's impossible, then that means there have to be infinitely many prime numbers. This is a very sneaky but also very useful way to prove that something is true. The actual details of showing why there are actually infinitely many prime numbers using this technique is a little bit too involved for what I want to do in this video. But if any of you are interested, I'd be happy to make another video explaining exactly how it works. Let me know. Okay. So we learned that there are these special numbers called prime numbers that are only divisible by itself and 1, and that there are infinitely many of these, meaning that we haven't found all of them yet, and actually we will never find all of them, which is kind of a crazy concept when you think about it. But so what? Does this actually help me with my life? Well, it might be surprising, but actually yes, prime numbers are very useful in our lives. They are used for something called cryptography, or encryption, which is actually how we keep everything on the internet safe. Things like passwords, or your email account, or bank accounts, things that we need to keep private, are all protected with something called encryption, and that relies on prime numbers. Now, imagine you have a secret message that you want to send to your friend. So you write it down, you put it in a box, you put a big padlock around that box, you lock that box, and you send it to your friend. How can your friend open that box? You have the key, and you definitely don't want to send the key to your friend. That key could get intercepted, someone could steal the key, and then use it to unlock your box and find your secret message. So how can you send the locked box to your friend and make sure they can open it without ever sending them the key? What if they have a key and a lock too, and they put their own lock around that box, they keep their own key, but they send that box back? Now, you have a box with 2 locks around it, one of which you can open and one of which your friend can open. So you use your key and open one of the locks, but the box is still locked, right? There's still one padlock that your friend put on around that box, so your message is still safe. Now you send that box back to your friend. Can you see what's going to happen? Your friend now received a box with just their own lock around it. So now they can open the box and read your message. This is actually the basic concept of how encryption works. And as I said, it all relies on prime numbers. If you're interested in how prime numbers would actually be useful in this funny story I just told about unlocking boxes, then stay tuned, because the next video I'm going to make is going to be all about how prime numbers are actually used in encryption, and how math is helpful in keeping everything on the internet safe. So today we learned what a prime number is, that there are actually infinitely many of them, and that they actually have some very useful real-life applications that we're going to talk about more next time. I have one final question I'd like you to think about. Go back to the definition of prime number, make sure you understand it, and then tell me, is 1 a prime number? Thanks for watching. Bye!